Welcome. This video provides a practical guide on presenting healthcare data. We will cover how to use tables, charts, and graphs for clear and effective communication, featuring over 20 worked examples. This video is organized into 4 parts, designed to mirror the actual workflow of data analysis. We move from foundational concepts to building tables, creating charts, and finally, ensuring the integrity of your presentation. It is important to remember that data are not information. Information is what data becomes after you interrogate them. A common failure is neglecting the analysis plan before collecting data. Why present data visually? Numbers in isolation are noise. Visuals allow you to summarize data, reveal patterns, and drive decisions. A good chart moves the conversation from validating numbers to deciding on actions. Before you create any visual, you must identify your variable type. Whether it is nominal, ordinal, interval, or ratio, determines which statistical methods and chart types are appropriate for your data. We now begin Part 1, Tables. Tables are the foundation of every chart that follows and serve as an orderly arrangement of rows and columns. A table is a structured grid where rows represent observations and columns represent variables. While they are precise and excellent for reference, they are less effective than charts at capturing attention or revealing trends. A complete table consists of 7 parts: title, headnote, box head, stub, body, total line, and the footnote with the source. Omitting any of these can lead to misinterpretation of your data. When building a table, ensure your title is descriptive, align numbers to the right, and use consistent decimal places. Avoid mixing units in the same column, and always use specific symbols for empty cells. For one-variable tables, we use a frequency distribution. This displays the category, the raw frequency, the relative frequency as a percentage, and the cumulative percent for a running total. To build a frequency distribution, you must find the range, determine the number of classes, calculate the class width, and set your limits. Remember, keep class widths equal to avoid distorting your data. Relative frequency allows for comparing groups of different sizes, while cumulative frequency helps identify medians. Use these tools to answer specific questions your audience may have. When dealing with 2 or more variables, use cross-tabulation. This technique exposes relationships between categories. However, keep it simple. Beyond 3 variables, it is better to switch to a chart. It is essential to distinguish between ratios, proportions, and rates. Always provide the denominator, as counts describe workload, but rates are required to describe true risk. Finally, how do you choose between a table and a chart? Use a table for precision and reference, but use a chart to highlight trends and comparisons. Often, the best approach is to include both, the chart in the slide and the table in the appendix. We move now to Part 2, focusing on charts and graphs. These are the most effective means for visualizing relationships in your data quickly. This is our chart family. We categorize 12 common forms into 3 groups, each matched to specific data requirements. The core rule is simple. Categorical variables use separated bars or slices, while continuous variables use touching elements. Here is the anatomy of a chart. From a clear title that states your finding to essential items like axis labels, units, and source citations, every component serves a purpose. Remember, your title is your argument. Bar charts are the workhorse of healthcare reporting. We use 4 main forms: simple, grouped, stacked, and 100% component bars, depending on whether you are comparing categories, subgroups, or looking at composition. This simple bar chart is ideal for a single categorical variable. Design rules are key here. Keep it horizontal for long names, order bars by value, always start at 0, and avoid unnecessary colors. It is critical to distinguish bar charts from histograms. Bar charts represent discrete categories with gaps, while histograms represent continuous data with touching bars. The shuffle test is simple. If reordering the bars loses meaning, it is a histogram. Grouped bar charts allow for comparing subgroups side by side. Limit these to 3 subgroups to keep them readable, and ensure your category order remains fixed throughout the chart. Stacked bar charts show both totals and composition. Because the middle segments float, only the bottom segment shares a common baseline. Use this carefully, and keep your stack limited to 2 or 3 segments. For comparing proportions across categories, use 100% component bar charts. They normalize all bars to the same height, making comparisons easy. Always include the sample size n for context, since absolute counts are hidden. A Pareto chart is a ranked bar chart with a cumulative percentage line. It is your best tool for identifying the vital few causes in a process, allowing you to prioritize improvement efforts where they will have the most impact. Pie charts remain popular for part-to-whole comparisons. Stick to a maximum of 5 slices and always include an other category if needed. Start your largest slice at 12 o'clock and proceed clockwise. When sizing a pie slice, you convert proportions to angles. Multiply the decimal proportion by 360 degrees to get the sweep. This simple arithmetic helps verify that your data forms a true, exhaustive whole. Histograms show the frequency distribution of continuous variables. Bars touch because the data is continuous. They reveal important insights like the center of the data, the spread, and whether the distribution is symmetric or skewed. Understanding the shape of a distribution is crucial. Most healthcare data is right-skewed, meaning the mean often overstates the typical patient. In these cases, reporting the median is almost always the better choice. Finally, the frequency polygon is effectively a line chart derived from a histogram. It excels when you need to compare multiple populations on the same axis, where standard histograms would become cluttered and unreadable. Next, the box and whisker plot, an efficient way to show the median, spread, and outliers for several groups in one view. The box captures the middle 50% of cases, while the line inside marks the median, which remains stable even with extreme outliers. The whiskers extend to the remaining values, with outliers plotted as individual points. Line graphs are the standard for trends over a continuous axis, typically time. They accommodate more data points than bar charts and allow you to track multiple series simultaneously. Label lines directly to maintain clarity and always mark significant interventions on the x-axis. Run charts take a line graph a step further by adding the median as a reference. This allows you to distinguish between random noise and meaningful changes. Look for signals like shifts, trends, or outliers to determine if your improvement project is having a real impact. Control charts are vital for management. They include a centerline and control limits calculated from the process data itself. This helps distinguish common cause variation, the noise inherent in a stable process, from special cause variation, which represents a change that requires investigation. Scatter diagrams help visualize the relationship between two continuous variables. Each point represents a paired observation. A tighter cluster of points indicates a stronger relationship, while a curve suggests a nonlinear one. Remember to put the presumed cause on the x-axis for easier interpretation. Remember, correlation is not causation. Even with a strong scatter, consider other factors like chance, reverse causation, or confounding variables. Before assuming a causal link, look for temporal precedence, a dose-response relationship, and biological plausibility. Maps and pictograms are ideal for geographic questions or public communication. Use spot maps for clustering, choropleths for rates, and pictograms for simplified counts. Avoid scaling icons by height, as this disproportionately increases their area and misleads the eye. We have reached part 3, where we address integrity in presentation. Every design choice acts as an argument, so choose carefully. The goal is to ensure your presentation represents the data with honesty. Charts can easily mislead through default settings. Watch out for truncated y-axes, which exaggerate differences, pie charts with too many slices, which become unreadable, and 3D effects, which distort proportions. Always stick to flat, 2D charts and start your axes at 0. Beyond the basic traps, be wary of two-point comparisons, which ignore natural process variation, chosen baselines that mask real performance, and counts presented without denominators. Context is key. Show the full history, not just selected snapshots. Strive for high data ink ratios. Remove unnecessary grid lines, shadows, and redundant legends. Keep the data prominent, include one meaningful reference line, and use a single accent color to highlight your main point. If your slide works in grayscale, it is accessible to all. Selecting the right chart comes down to the variable type and the question at hand. If multiple options fit, choose the one your audience is most familiar with. Familiarity often outweighs elegance in a professional meeting. Use this checklist before finalizing any slide. Does the title state the finding? Are axes labeled clearly? Is the denominator included? Most importantly, ask, could an honest reader reach a different conclusion? If they can, you need to revise your presentation. To summarize, follow these 6 rules. Start with the variable type, match the chart to your question, always show the denominator, plot enough history, keep the design simple, and state your conclusion in the chart title.